So yeah, welcome to week 3 for the class about Android fundamentals. Today I want to do logistics, and in particular, assignment 1 or project 1 comes out, which is a tip calculator. So I want to just spend a bit of time talking about how you can get the handout for that and you can know how to start working. Then I want to spend a bit of time talking about how to submit the project. And in particular, I think for some people, Git and GitHub might be new, but even if it's not new, there's a very particular way that I want you to submit your GitHub project. And so I'm going to talk about that for about 20 minutes. And then for the remainder of the class, I want to talk about layouts and views on Android. And you'll get practice with that when you do the tip calculator project. Any questions before we dive in? Perfect. So you all have seen this diagram for a couple of weeks now. We're at week 3, which means that tip calculator has come out. So in order to access the assignment, what you can do is go into Canvas, go into the assignment section, and you should now see a PDF file which documents what is the requirements for the assignment. And actually, I want to spend just a minute showing you that. So here's what it looks like. We talked about this, I think, in the very first class, just basically the structure for how you can submit assignments. So there are 3 parts. One is, well, first of all, the due date. So the project is due October 11th, which is in a week and a half. So next week, I'll remind everyone again during lecture, like at that point, you should really be focusing on extensions, but hopefully you'll have the majority of the project done by next week. But then the project is due a week and a half from now on Sunday, October 11th. After that, there's a partner feedback component that is due before class on 2 weeks from now. So like at week 5. And there are 3 parts to each assignment. One is there's a walkthrough video, which is linked here. And you're going to use that to complete a basic working version of the class. Second, you have to do at least one extension beyond the video. So it's not enough to get credit just to do the video. You have to do at least something where you're on your own, essentially. And the idea here is that it could be a simple extension, like maybe adding a different styling to the app, or it could be something which is much, much more involved. The idea being, low floor, high ceiling. So you can take it as far as you want to go, but there is a minimum that I want everyone to meet in order to get credit for the class. And then finally, the way you submit this is you're going to submit your GitHub URL link to Canvas. And Canvas will randomly assign you a partner. And then what you can do, if you scroll down, I'm going to skip down to the very bottom here. After the due date, which is October 11th, you're going to give your partner feedback within Canvas itself. And there are 2 questions I want you to answer. I don't want this to take more than maybe 15 minutes. So if you're spending like an hour on it, you're spending too long. I want it to be quick and lightweight. I want you to document for me and for your partner. This is public feedback. Your partner will be able to see it. I want you to document what extensions did your partner complete. And second, I want you to basically give feedback, which is what did you like about the project? And then what improvements can you suggest? And improvements could be either stylistically, like, in Kotlin code, you don't typically write things like this. It might be better to consider writing it in this way. Or you might give feedback functionally, which is, you built this feature, and I feel like in terms of usability, you could have maybe tweaked it in a certain way, or you could have added this thing, and that could have been really cool. So basically, I just want people to interact in the class through this kind of structured way. So in terms of extensions, if I go back up a little bit, I listed here a bunch of different extension ideas. Some of them probably would take you 10 or 20 minutes, and some of them could take you a couple hours. So that's where I gave some pointers here to if you want to learn more about how you might do this. So feel free to click on that. If you're stuck anywhere for more than half an hour, come and talk to me or post a question on Piazza. The goal is I want you to build things. I don't want you to be stuck anywhere for beyond 20, 30 minutes. So as you plan out your week, here's what I'm suggesting. If you look at this walkthrough video playlist, there's 4 videos in there. It's about 1 hour worth of content. But because you're going to be building the app with me, you're going to be writing the code, you're going to have to stop and pause and play the video. So you should budget around 3 hours to go through the walkthrough video. So once you have the walkthrough video completed, that's done with number 1. So 3 hours for that. Then the extensions, you can budget however much time you want, like ideally maybe 1 or 2 hours more. And then, so basically, if you budget around 5 or 6 hours, that'll be plenty of time for you to submit on October 11th with a really high quality project. And by the way, I did update last night the 194A website. So This is also linked from Canvas, but if you want access to any of the slides or the videos that I linked, they're all over here now. All right, any questions about this? Cool, and so let me just show you, just for fun. This is a GitHub project over here that it's basically the tip calculator, which is where this assignment got inspired from. But you can see this is a GitHub project from 4 years ago. Okay, this is my project from 4 years ago, but it's an iOS tip calculator. So back then I had in my head that I would be both an Android developer and an iOS developer. That it didn't really work out. So I just dabbled in iOS a little bit. But you can see here, this is what I want your submission to look like. I want you to be able to say, like, here's a project name. I want you to have this like formatting, and I'll show you how to do this in a little bit. But basically you can document what you've done. And I want you to create a walkthrough of the main features for your app. So here you can see I have a GIF or a GIF, depending on, how you lean. And it shows you kind of what are the main features of the app. So I want everyone to submit their project in a format similar to this. Good. Let me just make sure I have the chat window open, so if people are chatting, I can see it. Okay, so if there are no questions on that, let's talk about Git and GitHub now. So I want to first talk about the theory of Git, but at the end of that theoretical portion, I actually want to go through an exercise with you and show you how to submit the project as per the guidelines I have for the bigger number project. So this is the project that we've been working on for the past 2 weeks, otherwise known as the Berkeley admissions test. So I'm going to actually publish this to my GitHub. Actually, I already have one version of it published already, which is the one that I sent the link out for last week. But I want to do it again. And I want to show you how to format the README file in the way that I can give you a template for. So first of all, let's talk about the theory of Git. So just give me a quick thumbs up or a reaction in Zoom. Who here has used source control, whether that be Git or Mercurial or Subversion or anything? Cool. So I see a few thumbs up. So maybe half the people have. So it's not a big deal if you haven't. But basically, almost every company, I actually don't know of any company which doesn't. But if you go out into the professional world, every company will use source control. So what is source control, right? So the idea is that source control is software which will record all of your code changes for a project. It's a single source of truth for all developers. And that's really the key value of having a source control system, is that when you go out into the real world, you're going to be developing a project with a couple people, hundreds of people, maybe even thousands of different developers who are all contributing to the same code base. And so having a single source of truth is vital to being able to communicate and land changes in the code base effectively. And actually, it doesn't just have value if you're working on a large team. It also has value if you're working alone. So in terms of key functionality, one of the things that's valuable, even if you're working alone, is that you have the ability to revert back to files from a previous state. So one of the things that's magical about software is that you can change things so quickly. And basically, you can move really, really fast. However, one of the downsides of that is that you also break things really, really fast, right? And so especially as your project grows in complexity, you might make a change, which seems like an innocent change, but actually has a downstream effect where things get broken. And so one of the key functionalities of Git or source control is that you can figure out, okay, here's a change that landed, and I can now go back to prior to that change, so that the functionality that I care about is restored. Another key change is basically what I just mentioned, is that over time, your software project will keep evolving, keep changing. And if you want to be able to track how your project is changing, you can use source control for that. And that can be really educational as you think about modularity and architecture, and where is your code base growing in a way that you don't want it to, or how is it growing healthily, right? So that's one really key value of source control. Another big one is collaboration. So that one may not be as relevant for this class because you're going to be working on your own. But again, most projects you're going to be collaborating with people. And so there's a concept in Git called branching. And so the idea here is that you can be committing code, you can keep making code changes. And if you want to do something experimental, you can create a different branch for that. And on that branch, you can do whatever you want, which doesn't impact the main line, which is like the branch that most developers are pulling from. And so you have this really nice separation between different features or different code changes, and they don't have to impact other people. And finally, there's a really powerful concept called blaming a code change. And blaming has this negative connotation because it almost sounds like, you're faulting someone. But it can certainly be used for that in the sense that, okay, there's a bug that got introduced. And then what I can do is I can git blame a file where I think the bug got introduced. And I can figure out here is the person who caused that bug and then go make them the owner of that bug, right? However, it can also be used in a really positive way. So for example, when I move on to a new team or a new code base, the very, very first thing I do is I look at who is a really strong tech lead or a strong engineer on my team. And what I'll do is I'll look at her changes. So I'll get blame on her changes. I'll find out all the places where she has committed code, and I'll just look at what were her code changes. And oftentimes that's really, really educational to look at a senior engineer and figure out here's how they design their code, here are the practices they use, here's what they don't do. And you can apply that for your own project. So using git blame on people that you respect is really valuable. Am I missing something? So for people who have used Git, I'd love, as we go through this, like share your experience as well with what do you use Git, what do you use source control for, and what do you like or don't like about it? So Git is an example of a source control system. And in particular, it's a distributed source control. It's distributed version control. So there's actually many, many different kinds of source control. One is Git, which is probably the most common. I think most companies by default will use Git just because I think most people have an awareness of Git. Mercurial is another one. And in fact, at Facebook, which is where I work, we use Mercurial. So I would say like Git and Mercurial are the two most common. And then Subversion was popular a while ago, like a couple decades ago, but I feel like it's not as frequently used now. So I left here in the slides, which you have access to, a link to a free book about Git. And so here's the thing about Git is that for the most part, if you follow the happy path, it's not that complicated. But as soon as you deviate from that happy path, as soon as something goes wrong or you deviate from like the normal workflow, Git becomes really complicated really quickly. And so if you're planning to be, a software engineer in industry and you want to go deeper, which I recommend that you do go deeper in source control, you should check out this book. It'll talk much more about kind of the nuances of Git than we'll talk about here. Just because for the happy path, I think most of you will be fine. But when things go wrong, to get yourself unstuck requires some more expertise. And that's why I'd recommend going through this book. So high level, talking about the mechanics of Git, right? So the way it works is there's a concept of a working copy and a repository. So your working copy is basically the current version of all the files in your project. So for example, in an Android project, we'll have a main activity.kotlin, which is where you have the business logic for your application. You have activity main.xml, which is where you have the views or the layout for your project. The working copy is basically the current version of those two files, along with a couple others. When you make a change to one of those, you will commit that change. So you'll write a message that says, I updated the logic for my bigger number game. You'll commit that change, and that will be stored inside of the repository. And so you can keep making commits, and that will essentially form a tree or a graph. And you can basically visually, you can represent each commit as one of these circles. And going back to what I said earlier, this idea of collaboration and branching, the powerful thing about Git is now, let's say I want to make an experimental feature, which only I want to play around with. I can make a branch, and I can start making commits on that branch. So you have this really powerful branching ability. You can share code. You can jump back and forth between different parts of your tree in like basically one command. So now you know what Git is. You know what source control is. What is GitHub? GitHub is a website or community that provides hosting for Git repositories. So if you look at GitHub, it's really actually trying to be a social network in some sense around Git. And that sounds a little bit weird, but it's actually, I think they're doing a really good job. Basically, like you have different repositories, and many of the repositories on GitHub are open source, and you have functionality to be able to see what repositories are trending, or you can star a repository or file an issue on a repository. So it's a really nice kind of collaboration feature that GitHub allows you to do. It's all through the website. So you don't have to actually have like downloaded the repository on your computer. It's all done through your browser. Just maybe let's do this. Give me a thumbs up if you don't have an account on GitHub. I'm imagining at least some people or most people should have an account on GitHub. Okay, yeah, so it's super easy. If you don't have an account on GitHub, you can create one with your Stanford email address or create one with your personal. It's totally free, and then you'll be able to create repositories and share them through GitHub. And if you have trouble with that, just let me know and we can walk through that together. So now I want to talk about the distributed part of Git, right? So Git is a distributed version control system. And I just want to touch on this a little bit. So basically, you already saw this diagram where user number 1 is working on their Android project and they have a working copy. They'll commit something and that'll be in the repository. And the repository will also say, hey, here are some updates that other people have done. And you can do git pull. Git pull basically means I want to get updates from the repository. So the reason why Git is called distributed version control, that this diagram actually lives on every single person's computer. So all the other developers on your team will have a repository and a working copy as well. And the broker, the person or the software which manages all those changes between the repositories, that's what you have a hosted cloud repository. And typically that'll be hosted on GitHub, or maybe you could have a separate server for that. But basically, that server is the source of truth, which is the broker between all the different changes that are happening on everyone's laptop. And so the workflow is that you'll make a commit. And when you want that commit to go and be shared with everyone, you would say git push, which would then take your commit or set of commits and push it to the cloud. And then when someone else makes a change and you want to grab those changes, you would say git pull, and that would be updated in your repository. So now I want to actually jump into Android Studio and just show you kind of what this looks like. Any questions about kind of the theory of this before we do that? What questions do you have? All right, lovely. So Android Studio. It turns out Android Studio has a really nice integration with Git built into it. So you're welcome to use that, and I'll show you how to use that. Some people, if you are familiar with Git, you can also do commands with Git on the command line, on terminal. And so for people who have done it before, it might be a little bit faster to do it on the terminal. But if you want to do it through the kind of tool menu, then you can also do that. So let me show you what this looks like. All right, so this is the bigger number game that we had from last week. And actually, I'm not even going to run it because it's not that interesting. The interesting thing I want to show you is how do we submit this project to GitHub, or how do we modify the project and make changes on GitHub. So I've actually already done creating the GitHub repository. So let me show you. I go into VCS. VCS stands for Version Control System. And I can go to Git. And then I can say remotes. So the cloud server, which manages all of which is like the source of truth for Git, that's called a Git remote. And by default, you have something called Git remote origin. And so the default name for your first remote is origin. And you can see that the URL, like the server where the origin repository is located, is this URL. And so if I open that up, it's right here. So it's my GitHub handle, and here's a project name. And then I have all the projects for this Android project located here. And so let's say I wanted to make a change now. So remember how if the user answered correctly, like they picked the correct answer, they picked the larger button, then the color is turned to green. And if they got it wrong, they turn it to red. So let's say that we're working on a team and our designer comes to us and says, hey, we don't want it to be green. If the answer is correct, we want it to be cyan or like some other color. So I made the change. Now what I can do is I can go into the VCS tool window, go to Get, and then say Git add. I guess I should say Git commit. So I can go to commit and say commit file. And so here, let me see if I can expand this. Okay, so at the top over here, it shows me here are all the things that have changed in your project. So it says in the app directory, there's a file called main activity.kotlin. That's the one that we touched. And there's a one-line change. So you can actually see the diff right here. So I changed it from green and I changed it to cyan. That makes sense. It turns out there's one more change that happened here. This is called, let me see if this is called the inside of the .idea folder. This is something you don't have to worry too much about. So you can kind of ignore changes inside of this. Basically, these are configurations for Android Studio. So there's some kind of change that happened as a byproduct of me moving my mouse and changing the UI of Android Studio. So don't worry about this. We can go ahead and commit it. It doesn't really matter. So I select both. Now I can add a commit message. I can say update color to cyan. And now I can tap on this button, which says commit. And now you can actually see the commit. So if I'm going to go to terminal just because I'm a little bit more familiar with the terminal, I can say get log. And get log basically says all of the different commits that I have in the history of the repository. And so you can see here, there's a commit hash, which is auto-generated. I'm the committer. Here's the date. And then here's my commit message. So now the question is, how do I push this? How do I update the cloud repository, right? So like right here, you can see the last change was 30 minutes ago. I want to have this change be reflected. So I can go to VCS, Git, and then I say push. And I'll confirm it. And it's asking for a password here. And then just keep your eye on the bottom here where it says updating or pushing or whatever. So now if I come back to GitHub and I refresh the page, yeah, so now it says 1 minute ago. And it has that same commit message that I had, update color to cyan. So that is a typical workflow. So what I recommend most students should do is create a brand new project on Android Studio. And that should be your first commit. Just make it like a starting brand new project commit. And every time you hit some milestone in your project, you should make a new commit for that. What most students will do is actually just wait until the very end and commit everything in one large commit. And that works too, but you lose a lot of the power of Git if you do that, right? Because the point of Git is to kind of track your changes slowly so you can go back and forth as needed. Yeah, so there's a question here. What happens? Sorry, is there a question? So what you can do, can you open up the terminal tab? And then inside of terminal, let me expand this so you can see a little clearer if I can. Can I zoom in here? Oh. But basically, in the root of your directory, just say ls-a. Okay, so ls-a means I want to see all the files here, including hidden files. And so what I'm suspecting is happening for you is that you may not have this .git directory. Whenever you have a chance, can you just let me know if that's accurate or not? But basically, the .git directory is a hidden directory which stores all of the history of your commits. And so if you don't have that, what you can do is just say git init, and that will actually create a new repository for you. And once you've done that, hopefully then inside of VCS, you should have a Git menu option. And if it doesn't show up for you, it's not the end of the world. Don't worry too much. My preference actually is to use the command line. So like if there are people who can't get the VCS to show up and you're having trouble, then I'm happy to, at office hours, or we can spend some extra time and I can show you my workflow, which is using terminal, which is using command line and not the menu option. But you can do whatever you want. At the end of the day, basically, as long as you're able to make a commit and upload it to GitHub, that's all that really matters. All right, and so the last thing I want to do from the Android perspective, I want to show you the README file, and I'll talk about what that is. But before we do that, just one more note um, about GitHub is that I just want to caution people. In GitHub, there's a concept of a public repository and a private repository. So as the name implies, public means that anyone in the world, if they go to that URL, they'll be able to see your code. Private means that they have to be authenticated and they have to be signed in order to, you basically have to give them permission in order to see your repository. And so what I'm advising is that I would like everyone to have a public repository, which is a default. And the reason is because that's better for building a portfolio, right? At the very beginning of the class, I mentioned that one of the purposes of 194A is I want you all to come out with 3 high quality projects that are essentially a portfolio piece or portfolio pieces. And I want you to be able to share that with people. And of course, in order to share it with people, it should be public. The other thing is that one of the components of this class is I want people in the class to give you feedback. And so just it makes it easier if your repository is public. So if you don't want to make your repository public because for whatever reason you want to guard your code, or if you want to publish your app and you want to make a company out of it, that's totally that's a fine option. Just then send me an email and we can work out the access policy. So I need to get access to it and your partner should get access to it and we can work that out. If you do have a public repository, the one thing you should be careful of is what you put on GitHub. Because if it's public, anyone can search through your code. And so if you have something like a secret API key or an access token, which is basically a way for you to access some privileged resources, that should not go inside of your Git repository. And the way you guard against that, or the way you make sure that some file is not in your Git project, is you have a git ignore file. And so if I go back to Android Studio, and you say ls-a, by default, you should have a git ignore file inside of every Android Studio project. And so if I open that up, Android Studio will automatically add in a bunch of these. So how we talked about the .idea? These are basically configurations or properties of Android Studio, which don't actually matter for other people on your team. And so these should be ignored. Similarly, if you have any kind of secret tokens or access tokens, those should also be in the .gitignore. Okay, so last thing I want to do here is I would like to talk to you about how to submit. Okay, so hopefully in the next week, all of you are at the point where you have this kind of project on GitHub. If you go to the assignment handout, right here. So the quirk or the unique thing that I'm asking everyone to do is include a readme.md. So does anyone know what a readme.md file is? Can someone help me out? What does it mean to have what does a readme file typically do in a project? Perfect. Yeah, you actually answered the second part of it as well, which is what is an MD file, right? So Clara just mentioned readme is typically what you use to instruct other developers or other people what is inside your project. How do you set it up? How do you install it? How do you use it? And going one step further, there's a special extension called the readme.md. MD stands for Markdown. And Markdown is a very simple but powerful way to format your document in plain text. And that's what I want to talk about just for 2 minutes, and then we'll be done with this Git and GitHub topic. So with every project, I'm going to give you a readme.md template. So for the tip calculator, here's what it looks like. And so I actually have a separate one for the bigger number, for the bigger number game. So I go back to the slides. I have it linked here. Yeah, okay. So this is the README that I provided, that I basically made for the bigger number app. So what I'm going to do is I'm going to copy this. I'm going to select everything, copy it, go into Android Studio. And what you should do is at the root of your project, create a new file. And you should call this README in all caps .md. And then Android Studio will prompt you, do you want to add this file to Git? I'll say, yeah, I do want to add it. And then I want to paste in everything. And so this is what Clara was talking about, is that you have this kind of plain text formatting, which actually on GitHub, the website, it'll automatically render this in a really beautiful way. So I'll just quickly you don't have to know too much about it. I want to quickly talk through it. This $1 means make it a header, make it large text. 2 £signs means make it a header, but with smaller font. And then normal text is like paragraph p tags, basically. And so what I've done here is in each template, you have to fill out certain information. So I'm going to fill this out. And then there's some stuff that I can leave as default. Bigger number game, aka cal admission test, prompts the user for which is larger, and so on. Basically, for someone who I want to show this project off to, this will explain to them in a really nice way what I've done. And I spent like 10 hours on this, right? Here, these are checkboxes. These will be rendered as checkboxes on GitHub. So the way you want to fill this out is you actually put an X for everything that you did. So user can select one of the two buttons. So I did that. The user sees the background color change. I did that. And the user will see distinct numbers displayed on the buttons. I did all three of them. And now I also did the extension, which is I made a different color. So instead of using green for correct, I used cyan. And then anything else I could add right here, but I didn't do anything else. I'm going to delete that bullet point. These asterisks here are rendered as bullet points. So now I am going to quickly just fill in a couple more of these. And there's a section here about a walkthrough video. And I'm actually going to come back and do this in 2 minutes, but I first wanted to show you what this will look like when I upload it. So I'm going to go back into terminal. I'll say git status. And so you can see that, the readme.md file got modified. And it looks like I have a change in main activity as well. I'm not sure what that is, but let's ignore that for now. I'll just say git commit, and I'll say added readme. And I'm going to git push. Cool. So this basically is a message which says that, hey, you were able to successfully take your changes locally and push it. So now if I go back to GitHub, I refresh the page. So here's what it looks like. Readme.md, if it's located at the root of your project, GitHub will automatically pull it out and display it when you go to this project page. And so this is what I'm talking about with the formatting. So it has this kind of bold font here. It has these paragraph tags, these checkboxes, and so on. So this is what I mean by when you come out of the class, I want you to be able to have 3 of these high quality projects that you can show off and put on your resume. The last piece of this, which I think is really important, is the walkthrough video. So the idea here is that I want you to create a GIF of your project. So there's actually many, many ways to do this. And this is an example of, I'm not going to tell you exactly how to do it. I just want to tell you why. But basically the why is I want you to have a walkthrough so that anyone who wants to come and see what you did, they don't have to actually download your project and install it and have an emulator set up to see your project. That's too much work, right? If you have like your parents, your friend, or a recruiter who wants to see your work, they should be able to look at this README and quickly at a glance understand the complexity of your project, the design aesthetic of your project, and so on. So the way that works is you can open up QuickTime. So now we're getting into the how of doing it, and I actually don't care how you do it. There's a software called Licecap, which allows you to do it, and I have it linked here. The other way to do it is with QuickTime, and then I can show you very quickly how to do that. So let's run this. It's a build error. Okay, looks like I misspelled color. Okay, so I have the project running here. So now going back to QuickTime, what I wanted to show you is I can go to new screen recording. So I go to File, New Screen Recording, and I can kind of just record this part of the screen and then hit record, right? And I can show people, okay, here's the main user flow, the user stories of the app, right? And when I'm done, I can hit that stop record button up here, and I have now an MP4 file. Now the step is I need to convert this MP4 file, a video file, into a GIF. So the way I recommend doing that is gifs.com. And then you can actually like upload a MP4 and it'll turn into a GIF for you. So that's one way. The other way is what I linked here is something called Licecap. which will automatically create a GIF for you. But however you do it, you'll end up with a GIF. So I already did that. Let me open it up for you. So I have the GIF here. So now what I can do is I copy the URL, go back to Android Studio, go into the README, and then right here, I'm going to replace this URL where it says the source of this image tag and paste that in. And do the same thing. So let's commit this. Update README with GIF, and then push it. All right, so based on that, it succeeded. So now let's go back to GitHub and let's refresh. Yeah, so now I refreshed and you can see here was the GIF that I had recorded a couple days ago. So did that make sense to people? So now when someone comes to your GitHub profile, like your partner, they should be able to very easily see, okay, here's what, you know, that person did for the project. So that was a lot. Any questions? What questions do you have about the submission process? Nothing? Okay, so as you get stuck, then feel free to reach out to me. Like I said, I'm available on office hours, Piazza, just send me an email and then I'll help you with whatever you need. Nothing about GitHub or the submission process? Then we'll move on. Okay, so it's 4:45 and now we have until I think 5:20. So for the remainder of the time, I want to talk about layouts. So layouts on Android are fundamental to building any kind of application because layouts essentially are what you see on screen. So anything which you render onto the screen is a view or a layout. So let's just do some background. I've talked about this before. What is an activity? An activity is basically a screen on Android, and that's where we write all of our application logic. So we handle user interaction. So user tapping on a button would be handled inside of the activity class. You can update the text of something on the screen or change what's on the screen in your activity. And you can tell views to update. All of that happens in the activity. So where do layouts come in? Layouts come in because in the activity file, you're going to be pointing to a layout. So that's what is on line 10, where we say set content view r.layout.activity main. That means that the activity main.xml file, that is what will be used to render main activity. So now we can talk about layouts. Layouts are the things that we define in XML. XML is basically like the structured way of describing data for your layout. And I have a slide for that in 1 or 2 slides. So layouts will consist of various views. There's a text view, which is basically a label, putting some text onto the screen. An image view is super common. It's how you display images. A button is something that the user can tap on and get feedback that they're tapping on something. An edit text is a editable text view. So basically it's like a field where you can input your name, email address, or whatever. And there's many, many more. So like most layout design systems, there's like 4 or 5 views in Android that you're going to use a lot. And there's also a long tail of several dozen views that you'll almost never use. And so I want to just talk about these most common views. And there's a lot more that you can actually experiment with and play with on your own time, but you're not really going to use them in most kind of common apps. So when you talk about how do you update the different layouts, this goes back to, I think we've seen this picture before, right? The idea is that every layout or every view will have an ID if you want to change it. And then you reference that ID in your activity file and you set some method or attribute on that view. So in this example, we're updating the text of this text view. So let me just show you that really fast. I go back to Android Studio, and then we talked about how in main activity, we have this line here called set content view. Let me zoom in. So I'm going to command click on activity main, and that opens up the layout. So there are 2 ways you can actually look at the layout file. One is the code tab, which is this one. and the other is the design tab. So the design tab is a visual representation of that. And so when I talk about the different types of views, all of those will be visible inside of the palette. The palette is basically a way for you to drag and drop different components onto your layout. So we talked about text view, button, image view. Recycler view is a bit more advanced. We'll talk about that in, I think, 2 weeks. Recycler view is the standard way that you render a list of items. And if you actually think about most applications out there, almost every application is essentially, at the end of the day, a scrollable list of items. Your Facebook newsfeed, your Twitter feed, your Instagram feed, everything is something you basically scroll through. So the Recycler view is fundamental to pretty much every Android app. So we have a dedicated lecture just for Recycler view. A fragment is something that we'll also talk very briefly about later on. Scroll view, switch. A switch is something that you can toggle back and forth. And then these are the most common components. And like I mentioned, there's a lot more out there. And you can kind of go through each of these to experiment with and drag them out on your own. So let's think back to the bigger number game. In the bigger number game, the two views at the top were both text views, right? These are both labels. And the two views at the middle of the screen are buttons. And so the main takeaway here is that these things at the top are both text views, but the reason why they're displayed differently is because you can style the same view in different ways. So you can have a different font or a different bold type or a different italics or whatever you want to do, or a different color on a text view, right? So these are both text views and these are both buttons. So when you build out the tip calculator, there's also the same concept, right? All of these on the left are text views. Even this thing on the bottom here, the footer is a text view. And then these are the kind of unique things. This is the edit text. And then this component here, where I can drag and select the tip percentage, that is called a seek bar. So one of the things I want you to understand about layouts and views is that there's a hierarchy associated with them. So a view is a very fundamental base class in Android. Pretty much anything that you can render onto the screen has to inherit from the view class. So for example, button. Button is a type of view. Same with text view, edit text, and there's many, many more. So let me show you that actually. If I go back into the code tab and I can command click on any of these to kind of go to the source. This is looking at the Android SDK code, the Android code. So here you can actually see there's a public class. This is Java code. So the Android like view code is written in Java, not Kotlin, but we don't actually care because we're not really going to be modifying it or touching it. But here, the text view class extends or inherits from view, right? So that kind of makes sense. There's also a bunch of interfaces that it might implement, and you can read more. This is like a several thousand line file. So you can, whatever you want to learn about text view, you can learn through here. So there's one special kind of view called a view group. And a view group is basically a collection of views. So there's many, many types of view groups as well. Constraint layout, linear layout, relative layout, toolbar. And so the reason why I included this hierarchy diagram in the lecture is because I think it's really important to have that mental model. So for example, if there's a method on the view class, you now know that not only can you apply that method on a button, but you can also apply it on a linear layout, for example. And the reason is because any method that you can call on a view, you can call on a view group. Why? Because a view group is a view, right? That's what this diagram is showing. And because a linear layout is a view group, that means that a linear layout is also a view. So let me actually demonstrate that for you. Like we have this constraint layout, right? In this example, the root element is a constraint layout. So we have a background view here. I'm going to reference that. So in our main activity, we have a reference to btn left, right? So btn left refers to the left button on the screen, this one right here. And we are setting a click listener on it. So I'm going to do the same thing. I'm going to jump to the source, jump to the definition of this method, set on click listener. So you can see, do you see at the top here? This method, set on click listener, is defined on the view class. And so that immediately tells you a lot about where else I can call this method. So that's what I was trying to get at over here. So right here, I have the constraint layout, which has an ID of background view. So what I could do if I really wanted to, is I could say background view dot set on click listener. And then I could do whatever I want here. I can just log something. Right, and the reason this makes sense is because the set on click listener is a valid method on any view, and the constraint layout is one type of view. Does anyone have questions about that? So the views, I think, honestly, for the most part, the views are like, I'm confident that when you look at the view, you kind of play around with it, you'll understand it. So I'm not going to spend too much time walking through each view. I just don't think that's the best use of time. But I want to spend a little bit of time talking about each of the common view groups. So there's like 3 or 4 view groups that are really common that you're going to see if you build out Android apps or if you're inheriting a code base. So I want to talk about that. But I think for the most part, the views, you're going to kind of, as you need them, you'll pick them up, you'll learn them, and you'll be able to do whatever you want with them. Yeah, this is kind of what I just said, right? Layouts, view groups are a special kind of view that can contain other views. And there's essentially like a parent-child relationship here. The views that are inside of the view group are called children. And there are many kinds of view groups: constraint layout, linear layout, frame layout, relative layout. And so the reason why XML is a really good language to describe the Android layout is because exactly this slide. View group is a parent, and then it has different children inside of it. So you have a hierarchy, right? A really natural way to describe hierarchy is with XML. So it literally is. XML is a language designed to describe hierarchical data. So for example, views inside of a view group. Give me a thumbs up. Has anyone here worked with XML before? Nice. Claire has worked with it. Yeah, a couple people. Yeah, so like back in the day, maybe in the early 2000s or the mid 2000s, I think XML was actually a very common way of sending data back and forth between different services. And then that kind of came out of favor, and now I feel like JSON is more popular. But really what XML is and JSON, what they're both trying to do is they're trying to encode data. And so XML is not used so much for web programming and sending data back and forth on web, but it's still very, very commonly used for Android and other similar applications where you're describing hierarchy and describing data declaratively. And so the way it works is you have an element name. That's the first thing you have inside of this angle bracket. And then an element can have an arbitrary number of attributes, and each attribute has a value. So you can kind of think of this as a key and value. So adder1 has a value of this, adder2 has another value of that. And the XML element can either have children or it can't. And so if it has children, you would have all of that enclosed inside of the tags here. Or if there's no children, you would make the tag self-closing. So one important thing, I mentioned this in the Android Studio setup video, is that XML is case sensitive. So you want to be careful about capitalization when you do that. And then finally, I think this is a really important thing is as you type, Android Studio will try its best to be helpful. So let autocomplete help you. Let me show that to you. I go back to activity main. The first thing I want you to notice here is that there's indentation, right? So there's a concept of like a standard style. And so that style is there to help you visually understand what's happening. So here, because we have a space here, that means that typically anything which is indented one level by this amount of spacing, that is a child view. So what this means is if I can collapse all of it, the root element is a constraint layout. And inside of the root element, we have all of these views. We have how many? We have 4 views. We have 2 text views. We have the 2 text views at the top, and we have 2 buttons. And all of these 4 are without children, right? Like they're self-closing. So that's why there are no children inside of the text view. You can't have children inside of a text view. They're all self-closing. And then each of these, Android ID, this is the attribute name, and the attribute value is this thing. So here you have maybe like 10 or 12 different attribute values. And when I talked about autocomplete, what I mean by that is like as you start typing here, you can immediately see like there's a bunch of different attributes that I could fill out. For example, I could start typing, I want to add padding into my text view. So I can say padding, and I can add in maybe 10 dp padding. And I'll talk more about what is a dp and what is padding actually in a little bit. But basically, my main point here is let Android Studio help you with filling out whatever attributes you care about. Actually, there's one more thing I wanted to mention here, which is how do you actually add attributes, right? So I just showed you here, you can go into the XML tab, which is this code tab, and I can just start adding arbitrary attributes. There is one more way, which might be easier, which is to go into the design tab, and you actually have access to all of the attributes right here. So this is this option over here called attributes. So what I can do is I can select one of the components or views on the screen, like this 3, and then I can start searching for an attribute, right? I can say, I want to update the padding on this button. And then here you have the option here for like padding start, left, top, whatever. And I can just say, okay, I want to have a 30 dp padding. And you can see how that increased the padding size, right? And so if you're new to Android, which I'm obviously most of you are going to be new to Android, I actually would recommend you maybe should start with the design tab, just because the benefit of having the design tab is it'll tell you visually what are the different attributes available, like layout, width, height, and so on. There's no need to kind of guess what options are with the autocomplete. So padding and margin. This is, I think, a concept which is across all different frameworks like iOS and web. They all the same thing. The key thing to remember here is padding in, margin out. So when you have a widget or a component on the screen, you have the content, which is the innermost thing. But still within the view bounds of that view, you have padding. So that's what is this gray color. You're still inside of the view. So in terms of laying out the views onto the screen, it still is, the padding will still be inside of the view. Then you have a border, and then the margin is basically saying how much room do you want between this view and the neighboring views. Does that make sense to people? So the way to remember this is PIMO, P-I-M-O, padding inside, margin outside. Otherwise known as, please indulge my Oreos. Has anyone heard that phrase before? Please indulge my Oreos. No? I just made that up. There's nothing, there's no real mnemonic for this. It's actually really funny because I feel like, when I was growing up in grade school, they always used to teach me these mnemonics. Like, did you all have this? Like when you're memorizing the planets, I wrote this down because I never remember it. My very educated mother just served us 9 pizzas. And so that's like the way you remember, okay, Mercury, Venus, Earth, Mars, Jupiter, and so on. And I literally never could remember, like it didn't help me at all because I could never remember the mnemonic. And so it really didn't help me at all with remembering the planets. Did you all have that growing up? Yeah, so basically I tried to come up with my own mnemonic here. Please indulge my Oreos, but I doubt that it'll help you. But just remember, padding in, margin out, and I think you'll be fine. And I think it should become clear, like the more you kind of just play around with the different view hierarchies, it'll become clear, I think. All right, so there is a common question that I get, which is how do you decide when to use the design tab, which is what I just showed you, where you have that visual representation, or when should I use the XML tab? So here's what I recommend to students, which is you should probably prefer to modify things and update attributes in the design tab, but you should understand the XML. You should understand graphically, or like the one-to-one correspondence between the things in the layout and the XML. And if you go out into industry, what you'll find is that most professional developers will edit the XML directly. And that's actually a question I have for you. So can someone tell me, or someone maybe just guess for me, why do most people in industry, why do most developers in industry prefer to just go into the XML tab rather than using the design tab? Any idea? Interesting. Actually, the thing is that in the design tab, you actually have the capability to change the layout. Let me show you. So I'll go in the design tab. Right here, you actually have the option here to select what kind of phone do you want to have a preview of your layout on. Or I can say Pixel 3a, it's a little bit smaller. Or I can say on a tablet, how would this layout look, right? So I think that I don't think is one of them, just because you might be right that you have a lot more flexibility to seeing how your layout looks if you have a physical phone, because you have like something special, but you do have that capability in the design tab. So any other ideas? Like, why would I prefer to modify the code here rather than here? Yeah, I think I had two reasons why. That's exactly right. That's the first reason I had, which is what Kevin's saying. I don't know if people watched, I like put together that video on shortcuts. So typically, anytime you're doing any kind of task and you're doing it more than a couple times a day, it'll always be faster to have keyboard input to achieve that task rather than moving your mouse all over the place, right? Moving your mouse is a very slow input mechanism compared to your fingers on your keyboard, where you have 10 ways to provide input to the keyboard, right? So when you are doing Android a lot, what you'll find is that specifying attribute names by typing in XML is always going to be faster, especially when you have something like autocomplete with Android Studio. So that's one really good reason why I think you should kind of become familiar with XML. What is another reason why the XML, the code tab, is preferred instead of design tab? Any other ideas? Right. So the other reason is because when you go to any company of meaningful size, what you'll find is that you'll have company-specific abstractions. And what I mean by that is usually, I used to work at Pinterest, right? So at Pinterest, the designers would come up and say, we have our own way of displaying a text view onto the screen, or we have our own way of displaying a button onto the screen. We don't want to use a standard button component. We have our own way of doing that. And so what we have is we actually had something called a Pinterest text view, or a Pinterest button view, or like some kind of company-specific abstraction, which basically had the unique handling of how Pinterest buttons should behave under certain attributes, or how it should handle text wrapping, all these different things that we wanted to deviate from the platform in. And so whenever you have that, then you get a lot less value from the design preview. So like basically, imagine instead of here, what we're doing is this is a button component. Instead, what if we had a Pinterest button component, or like a company button component? Then the design tab typically will not be able to handle rendering that properly. And so as you get bigger and you introduce more layers of abstraction into your Android project, what you'll find naturally is that you're just going to get less and less value from the design tab, because it won't be a faithful representation of what actually shows up on your phone. So that is the other kind of key reason why what you'll find in industry is most people will just stick with the XML. Does that make sense? So XML is extensible markup language. And the idea is that there's no kind of logic inside of XML. Like, there's no concept of having a for loop or an if statement in XML. The idea of XML is it's used to declare how something should look. And so, for example, by having an XML element here for our text view, what I'm declaring is I'm saying that I want a text view here, and I want that text view to have certain properties. For example, I want it to have a margin top. I want it to have a padding. Here's the text I want it to say. The hierarchical piece of XML comes from the fact that there's a relationship between different elements in XML. And what that means is in this example, I have 4 different XML elements, which are all children of this constraint layout. So what I would say that this constraint layout is the parent view or the root element, and then it has 4 children. And the way you encode that is through XML by having this opening tag here. Like basically, this is a open XML tag and it's closed down here, right? And so that basically means that everything inside is a child of this constraint layout. Does that answer the question, Han? Basically, like XML is a way to declare data of a certain format, and the hierarchical part comes from the fact that you have children and you can have nested children inside of XML layout. Yeah, I think that's a pretty good summary. So XML is the way that we describe the layout. And so when we go back to the, like everything starts from the main activity. So like the main activity is really the brain. And when we go to line 15 and we say set content view, what this is saying is that the actual UI for this activity should be whatever is the component, whatever is the content of this activity main resource file. And that is this file. And so this file is an XML file, which describes the UI, like you said. That does bring up, I wanted to actually mention one thing that I forgot, is that like this formatting of XML is really important for readability. So what you'll find is like, as you start typing, you might just kind of have kind of unfortunate spacing like this, or, you know, like this. And so now, like when you do this kind of thing, it actually becomes much harder to visually understand the parent-child relationship, right? Because the indentation is off. So one shortcut that I like to use is Command Option L, and then it will automatically format all the lines for me so that all the indentation is correct. And so that will make it really clear what is the hierarchy. So just one tip I like to use. And if your partner doesn't do that in their project and their XML kind of looks off, that's something that you could comment on. That's a good question. Android : and app : are namespaces. So if you look at the top here, so this is called, it's okay. So I guess let me preface it by saying you don't actually have to know too much about it. Ideally, this is an abstraction that you don't have to peel off. If that makes sense. Like this is something that should just work. And you don't have to worry too much about it. But basically, yeah, it's a good question that you should kind of know as you go deeper in Android. Android and app are namespaces. So what you're seeing up here is that this layout file will contain 3 different namespaces, XML namespace. And there are 3 namespaces: Android, app, and tools. And the value here actually it's not super important. Basically, there are different attributes that live under certain namespaces. And typically the pattern is, the pattern is that certain attributes, like the common ones, live under the Android namespace. And then there are certain newer components that have attributes under the app namespace. So that's why like the constraint layout, which is what all these attributes are referring to, are corresponding to the constraint layout, which is a newer component in the Android ecosystem. And so that's why you have a separate namespace. And the tools namespace is also quite special, because tools as actually the only purpose of tools is for the design preview. So it doesn't have anything to do with how the layout will actually be rendered on your phone or on your emulator. It's purely for showing something in the design preview. So like here in this example, tools context basically is saying, I want you to link this layout file with the main activity Kotlin file, but really you could just delete this altogether and it would function the same way.
Okay, got it.
Yeah.
Thank you.
So TLDR there is namespaces are a way to categorize different attributes on XML elements, and Android Studio should help you figure out what namespace is appropriate. So let me just wrap up by talking about the different common view groups. So the most common, and the one that we're going to be using primarily in this class, is the constraint layout. So the constraint layout is somewhat new to Android. I think it came out maybe 3 years ago or 4 years ago, I believe, with Android Oreo or Pi. So like a couple years ago. And basically, a constraint layout is a new default layout system. And what that means is that whenever you create a new Android Studio project, constraint layout is the root element. And the purpose is that it's intended to create powerful and flat view hierarchies. And I'll talk about why that's important, what it means to be a flat view hierarchy. But basically, in a constraint layout, all of the children views are laid out according to relationships, otherwise known as constraints, between the sibling views. So if I go back here, we're actually using constraint layout here. And what I didn't go through this in the previous classes, but I want to just quickly talk through it now. So these are all constraints. So what we're saying here is, I want the ending constraint of this text view to be the same as the end of the parent. So I want the end of this, meaning like the right side of that text view, to be flush with the end of the parent, which is the edge of the screen. And I want the same thing on the start. And so what that has an effect of doing is it actually centers it right in the middle of the screen, because I'm saying I want it to be flush with the end of the screen and I want it to be flush with the beginning of the screen. And therefore, the constraint layout will compute that this text view should belong in the middle of the screen, which is what you're seeing here. And you can see it visually represented right here with that kind of squiggly line. And so you can have that same concept apply for any of the other ones. Here's an interesting one where we're saying this button left, the top constraint of this button left is relative to the bottom of the text view 3, which is this one up here. So if I go to the design tab, here's the button left. That's the constraint that we're talking about. So the top of this button is relative to the bottom of this text view. And the way you specify the distance is by, I go back to the code tab. Is the top and bottom. So like vertically, it's positioned right in the middle of the screen because the top and bottom are constrained to the parent. And it's relative to the text view. So yeah, the top and bottom are parent and text view, and the start is to the beginning of the edge of the screen. So you'll get practice with that in the tip calculator. The other really common root element or view group is called linear layout. And as the name implies, a linear layout aligns all the children in one direction. So you have two options, either vertically or horizontally. So in this example here, we have a linear layout, which has 1, 2, 3, and then 4 different components, right? So there's a concept of a weight where you can say, hey, I want to lay out all of these different views vertically, and I want one particular view in that linear layout to take up the maximum amount of height or width. And in this case, we're specifying that this component, the message edit text, should take up the maximum amount of height, which is why it's filling up the view. And then the send button is at the very bottom. Another really common one is relative layout. And relative layout is kind of in some sense deprecated because anything you can do with constraint layout, anything you can do with relative layout, you can now do with constraint layout. The idea of relative layout is that you can display children views in relative position. So for example, here, you can say that I want this component to be below this component, and I want this switch to be to the right of this view, and so on. I mentioned earlier how one of the powerful things about constraint layout is that you can create flat view hierarchies. And so what that means is, let's say that you're trying to build out this component for your application. There are two ways you could do this, right? One is you could have the root element be a linear layout, and then you have a horizontal linear layout, right? The first element is a image view, which is this thing. And then you have another linear layout, which is a vertical linear layout, right? And that's what you're seeing here. And that one has 2 text views. That's one way of doing it. A better way of doing it would be to actually use a relative layout. And with the relative layout, you can see now, instead of having a nested view group inside of a view group, you only have one view group, which is the root, and you have 3 views inside of it. And the powerful thing we're doing here is we're flattening the view hierarchy. When I say flatten, that means that the depth of the views is a lot less, is one less than what it is over here. And it turns out this has a meaningful implication on the performance of your application. The flatter your view hierarchy, the faster it is for Android to render your view. So always it's preferable to keep your view hierarchy flat. But that said, I actually don't want you to worry about that at all for this class. For this class, I feel like anything that we're going to build, it honestly won't matter too much in terms of performance. Like even if you have 4 or 5 levels deep of views, I mean, that's not ideal, but it's not going to actually impact. If you have like a modern phone, it won't be super impactful. So like, I don't think you should worry too much about this. This is like one of those things that is called premature optimization. And so I'd rather you focus on learning and doing whatever is comfortable rather than having to worry about this kind of stuff. That's it. That's all I had. So for next week, what I want you all to do is build out the tip calculator. It's about 1 hour worth of content through the video. And then I want you to then build out some extensions. And like I said before, if you're stuck anywhere for more than 20 or 30 minutes, stop what you're doing, write down what you're trying to do and what you already tried, and then come talk to me or post it on Piazza. Good? That's all I had. If there are any questions, I'll stick around. Otherwise, I'll see you all next week or at office hours tomorrow. Bye, everyone.